Okay, welcome back. We are going to be covering the falsifiability criterion in this chapter. I would like to make a comment about my YouTubing skills. Since borrowing the equipment that my friend owns, I am a little bit sad that my microphone doesn't sound as good as theirs does, so I apologize for that. But it is what it is. This is my microphone, so I'm trying to make it as good as I can, I swear. So, Chapter 2, we're going to be talking about the falsifiability criterion. And so before I get to what exactly that word falsifiability means, I wanted to introduce some concepts. So first off, we're going to return to a philosophical issue, which is the different ways that we can acquire knowledge from the world. There are a lot of different ways that we can acquire knowledge, and if you were to Google this, or if you have had a philosophy course, you might have learned some different ones. I'm going to focus on 4 specific ways of acquiring knowledge, and in this class, these are the 4 that I really want you to know. So, for example, let's say that there was a test question on a midterm that asked about the 4 ways of acquiring knowledge. These are the 4 that I would expect to see. If you showed me something else that is technically true, but is not what I was trying to get you to know and understand, it's not technically correct in the context of this class. So, little foreshadowing, given that this is something that's on your study guide for midterm 1, it shouldn't be a huge surprise that I'm going to ask you about the ways of acquiring knowledge. So these are the 4 ways that I want you to know. First off, there's the method of authority. I've got a nice picture of weather apps, right, that we might be relying on our phones. And it's funny because I have a different weather app than my husband has, who has a different weather app than my mom has. And so, for example, if it snows, we'll all sort of say whether our weather app predicted that it was going to snow. Oh, mine didn't say it was going to snow till this evening, or mine said that it was going to end by noon, or we all are sort of trusting the authority that has provided the information via our weather app, right? Because the truth is, we don't know. You might say to yourself, look out your window. Why do you need an authority to tell you what the weather is going to be like? Well, yeah, I know what the weather is right this minute, but do I need to take a jacket? Do I need to take an umbrella? Do I need a hat? You know, I don't know what the weather's going to be like later. So, given that I can't figure it out just by looking out the window, I say, hey, person who should know, right? The algorithm who has set up this prediction, what should I take? I'm going to go ahead and look at my weather app. So what we're talking about with a method of authority is that we rely on some kind of trusted source. Weather app, you might be relying on me to provide you with accurate information about the scientific principles of psychology. We trust authorities who are supposed to know more than we know, or who have established that they know more than we know. Our first ever authorities were our parents, and so we trust them to tell us the truth about things. So we can feel a little bit betrayed when we find out that things that they told us weren't true. I mean, from things that every parent probably tells their kids. There are probably a few parents who don't do this, but most American parents probably tell their kids that Santa brings them gifts, right? And so when kids find out that there isn't one, sorry if I blew anything for anybody, they're a little bit betrayed. They're like, what? You were telling me. But of course, with that one, you're like, well, I'm willing to keep pretending like I believe in it, though, because so I'm not really actually mad at you for tricking me. Right? But there are times when we find out that our parents have told us things just to make their lives easier, right? Like I have a friend who, when her kids were little and the ice cream truck would go by, she told them that it was the music truck. And let's all line up and listen to the music. And they never knew that that truck sold ice cream. That's a little bit of, trusting an authority who maybe betrayed you. Now, on my friend's behalf, she didn't want to be running out and buying ice cream for her kids every summer afternoon. So she said it's a music truck. I thought that was pretty clever. I wish I had thought of it. But the idea is, in general, there are people who may know more about something who we can trust to give us the correct information. Now, like my examples kind of illustrate, there are times when authorities might give us the incorrect information. It might be for their own purposes, like I don't feel like buying you ice cream, so that's a music truck. It might be because they are embarrassed of the truth. In families, a lot of times it isn't until you do, your Ancestry.com DNA kind of test and you find out some family secrets that nobody wanted to talk about. And you're like, wait, my mom and dad always told me this. And now I find out that it is objectively not true. There's like this big betrayal moment, but you have to remember that the authority may have had a reason why they didn't give you the correct information, right? So sometimes it's for very specific and meaningful reasons that the authority might mislead us. It could be because the authority doesn't really know, so they just make something up on the fly, which is really a big betrayal, because if I'm trusting you as an authority, I sort of need you to tell me when you actually aren't an authority on something. So they sometimes are giving us incorrect information for different kinds of reasons. So just because a person is an authority doesn't mean they know everything that we need to know about the subject. And so we have to be really careful about trusting authorities. The method of tenacity. This is where you cling to what you've always known. And I'm going to throw my husband under the bus on this story because when he was little, his mom apparently told her kids not to crack their knuckles because it would cause arthritis. So when my kids got to a certain age and started cracking their knuckles, my husband repeated that story. And I told him that, wait, there's a lot of data that shows that it actually doesn't cause arthritis. It's potentially even beneficial to crack your knuckles. So, I thought that he would go, oh, I had the wrong information. Let me switch my attitude. But he said, no, you're wrong. Everybody knows that. I've always known that you're not supposed to crack your knuckles. Everybody knows that. I've had a lot of students who agree with him. They're like, yeah, no, I've heard that too. You're not supposed to crack your knuckles. Now, the method of tenacity oftentimes evolves out of the method of authority. His mom told him cracking your knuckles is harmful. And so as an adult, he was still believing it, right? He's going to stubbornly cling to what he's always known. And he's like, wait, my authority, the greatest authority of all time, which is my mom, right? To all of us, to most of us, our moms are like, oh, infallible. Why would you tell me that it's harmful if it's not? It must be harmful. So even after I tried to show him, objective evidence that there was nothing wrong with cracking knuckles, he just told the kids, don't do it in front of me. If you're going to be cracking your knuckles, you have to do it someplace else. I can't stand it. So stubbornly clinging, even in the face of information that shows you that your belief is wrong, if you continue to believe it, that's through that method of tenacity, where you're like, I don't know, it's going to take a lot of different consistent sources telling me that what I know is wrong before I'm going to be willing to switch out what I've always known. It's something that we've studied a lot in psychology, this tendency for the first thing that we hear to be the one that really sticks with us. And so if the first thing that you hear is wrong, you're still going to cling to it. It's going to take lots of evidence to convince you that actually what you've always known is actually wrong. So this method of tenacity is very profound. It really sticks with us. And so we will stubbornly cling to false beliefs. We'll stubbornly cling to, sometimes it turns out our beliefs are correct, but we will cling. And so it makes us really resistant to learning how the world really works when we're stubbornly clinging to what we believe about how the world works. The method of experience is that empiricism argument, that we should really only trust our own senses, that we should go through the world using our own eyes, ears, touch, all those kinds of things to understand how the world works. So since I threw my husband under the bus, I'm going to throw myself under the bus on this one, because I've learned that I can't trust what I see. I literally cannot trust my own eyes. And it started really young. When I was it was the summer I was 12, that my family and I took a vacation up the California coast to Monterey Bay. And my mom and I were I think we went farther than that. I think we went all the way up past San Francisco and stuff. But my mom and I were really excited to go to Monterey Bay because at that time in my youth, the sea otters were really starting to repopulate the bay. And so we were really excited to get to see sea otters. And so my brother and my dad had something else that they were going to do while my mom and I sat on this bluff overlooking Monterey Bay, and we were watching for sea otters. And for the longest time, we didn't see anything. And we're like, man, there's no sea otters here. This is really disappointing. But we stayed because, the guys had taken the car. So we were sort of stuck there on this bluff. And slowly, over time, we started to see, oh, wait, I think I saw one. So we're attracting each other's attention. Oh, wait, I think I saw one. And then we started seeing a lot of them. And we started seeing them dive under the water and then bop back up. And we were convinced that we were seeing moms and babies, and we were seeing some eating. And now, remember, we're up on a bluff, so these sea otters are small in our visual field, and we didn't have binoculars with us. I think my brother and my dad must have taken them with them for some reason. I don't remember what they did. I was only 12, don't judge me. So we're watching them, and we're seeing all these things, and we're pointing it out to each other, and we're really excited, right? And we've got our little 110 cameras, if anybody knows what I'm talking about, these little cameras with these little tiny film in it and this little tiny lens on it. And so we're taking pictures that could not even possibly have come out, right? This is the old days before you could just look at it and know whether it came out. But we're, oh my gosh, all these pictures, and we're so excited we were seeing these otters. So my brother and my dad come back, and we're like, oh my gosh, look, you guys, you got here just in time. Look at all these otters. They get their binoculars out so we can see the otters better, and come to find out that none of it was an otter. Nothing out there was an otter. Everything that we were seeing was kelp. And we realized with the help of the binoculars that what we thought was the head of an otter, see how it's kind of like a light color? It was actually those balls that are on kelp that kind of keep them up towards the top of the water. They're full of air. And the reason why we hadn't seen anything at first is because it was high tide. And as the tide was going out, more and more of the kelp was being exposed. And then as a wave would come in, it would make it look like things were bobbing and going underwater and coming back up. And it was like quite the exciting experience until you could see that what we were watching for like 2 solid hours was kelp. Very disappointing. Ruined the whole thing for me. I very much more enjoyed that we were watching our otters. It's still a big joke in the family, and if I see an animal as we're driving down the road, oh, look, you guys, deer, no one will turn their heads because they think I am hallucinating again, that I'm seeing a bush, and it's, I think it's a deer or something. But from that experience as a child, I realized that even my own eyes will convince me of something different than what really is happening in the environment, right? That I can't even trust my own eyes. I can give you a number of other examples of, as an adult, me misinterpreting things that I've seen or heard. And then when I found out what it really was, it's like, wow, how could I have misinterpreted it like that? But I'm glad that these things have happened and that I've seen the evidence that my interpretation was wrong, so that I could really drill down that, the method of experience is not the most reliable way of collecting information about the world. That our own senses will fool us sometimes, that information coming in through our eyes, our expectation, our hope of what we might be experiencing can cloud can cloud the information that's coming in, and then our interpretation is what matters more than what actually came in through our senses. So I'm not a huge fan of the pure method of experience, and I think I mentioned that in chapter 1, right, that systematic empiricism, okay, let me make a prediction and see if it's supported by the data. That makes a lot more sense than just trusting my own senses. So these 3 methods of acquiring knowledge each have big faults with them and can really lead us to incorrect conclusions, right? If we rely on the wrong trusted source, we could have incorrect information for a variety of reasons. If we cling to something that we've always known, but that thing that we know is wrong, we could have the wrong information. If we use our senses, but our senses are being interpreted through faulty, logic, we could have incorrect information. So what's left? The scientific method. So I'm going to go back to the knuckle cracking example because I was able to find a nice picture that illustrates the science behind what happens when you crack a knuckle. And so the scientific method allows us to actually collect data and see what actually happens out in the world. So in this case, if we have a hypothesis that cracking your knuckles leads to arthritis, we could actually, there are a number of different scientific approaches we could take. In one approach, what you're seeing in this picture, we're actually looking at, okay, what is actually making that popping sound? I think a lot of people have assumed that the popping sound is the actual 2 sides of the knuckle rubbing against each other, or that the ligament that holds the 2 sides of the knuckle together is like snapping across the knuckle or something. And what they've actually found is that there's CO2 that builds up in our synovial fluid in between our 2 sides of our knuckle, and that when we crack it, it pops out. And that's why you can't really crack your knuckle again right after you just cracked your knuckle. If it was really just your knuckles rubbing up against each other or the ligament popping back and forth, you'd be able to do it repeatedly. The fact that you can do it once and then you can't do it again for a while means that, that CO2 probably has to build up again, and that releasing the CO2 kind of feels better. So one way we could do it scientifically is to actually see what is causing that popping sound, and is that thing that's making that popping sound actually harmful? Could it possibly lead to arthritis? The other way to look at it scientifically might be to do a longitudinal study where you start studying people when they're young and see whether they crack their knuckles or they don't, and then follow up with them when they're older and see whether they have arthritis as an older person or not. And they've done both of these kinds of studies, and what they've found is not only that you're releasing CO2, but also that people who crack their knuckles when they are older are no more likely to have arthritis than people who didn't crack their knuckles. So the scientific method, we're going to collect data and we're going to test hypotheses, and we're probably going to come up to much more reliable conclusions than using any of the other three ways of acquiring knowledge. So like I said, if you were to be asked a question about this on the midterm, these are the four methods that I really want you to focus on, and I want you to be really aware of what each of these are, and then the errors that tend to come with the first three, and the solutions that are provided by the scientific method, right? Like, you can fix all of these problems by using a scientific method rather than just trusting an authority or just clinging to what you've always known, or just even using your own senses. All right. So the steps in the scientific method are, first off, you have to define or identify the problem. You have to figure out, what are we actually talking about? So in psychology, we are what I like to call a kind of a baby science, because we've only really been practicing psychology as a scientific endeavor for about maybe 150 years, depending on who you're going to credit as the founder of psychology. But I'd like to point out that even though it was founded about 150 years ago, we've gone through a number of different phases of, approach to psychology and more or less rigor in our scientific method and stuff like that. So I'm going to say we're still kind of a baby science. And as a result of that, in a lot of ways, we're still trying to figure out what our problems that we're trying to study are. We're trying to figure out, like, what I think. I'm getting confused between these lectures that I'm doing right now for scientific principles and the lectures that I'm doing for my industrial and organizational psychology class. So because I was talking about, I think it was in that class, I was talking about intelligence testing. One of the biggest problems that we have in psychology is that we study a lot of constructs like intelligence, but we haven't even really fully defined what intelligence is, right? So it's very difficult for us to study certain things in psychology because they are abstract. They aren't concrete, observable things. Like if you were studying a hard science and your job is to sequence the DNA of a particular type of bacteria, all of that is very concrete, right? If you're studying psychology and you want to find out whether people who were born in 1935 have more or less intelligence than people who were born in 1965, well, okay, it's pretty easy to measure the year you were born, I'll give you that, but what do you mean by intelligence and how are we going to measure it, right? Like, so first thing we have to do is define the problem. Once we've defined the problem, in the field of intelligence testing, we've sort of moved to this next part because we're like, oh, okay, we'll keep arguing about what intelligence is. But next thing you do in a scientific method would be to form a hypothesis, which is basically a prediction, a testable prediction, right? So we're going to try and predict what's going to happen. Then we are going to test that hypothesis by collecting data, and then we're going to organize that data and analyze it using statistics. And then we're finally going to be able to answer the question, do these results support our hypothesis? If they do, if the data supports the prediction, the hypothesis that we set out, then we're going to draw our conclusions, we're going to report our results and say, these findings continue to support maybe the theory that drove our hypothesis, right? So we're going to go ahead and draw our conclusions and report our results. If the results don't support the hypothesis, now we have some questions for ourselves. Like, is it the case that our prediction was wrong? Or is it the case that maybe the way that I set up my study was faulty? So that if the hypothesis was in fact accurate, my study wouldn't have been able to really reveal it. So generally for most of us, when we have a failure to support the hypothesis, the next thing we do is actually just design another study. We try and look for any errors that we might have incorporated into this current study and try and improve it so that we can actually test the hypothesis. So we don't say, oh gosh, I was wrong. My hypothesis was wrong. The theory that led to my hypothesis is wrong. Instead, we say, easiest explanation is probably that I did something wrong. So I'm going to try and tighten up my study, we like to call it. Maybe use a different measure, or treat the participants slightly differently, or something like that. I've been doing a study for the past 5 years now, where so back in 2014, a researcher reported that just the mere presence of a cell phone while people are trying to do difficult cognitive tasks dampens their performance on the cognitive tasks. And in their study, they had 2 participants in the same room, and the researcher would set their cell phone down on one of the participants' tables, and the other participant didn't have a cell phone on their table. And what the researcher found is that the participant who had the cell phone on their table performed more poorly on the cognitive tasks than the participant who didn't have the cell phone on their table. And the interpretation was that it's distracting to have a cell phone there, and it took away some of the cognitive effort or cognitive capacity that the person could have been devoting to the task, and it interfered. And so the end of the study was, cell phones are distracting, and students should have to put them away, and employees should have to put them away because they're so distracting. So I saw this report, and I thought, well, this is a really good opportunity for what I was talking about in Chapter 1, a pure replication. Like, I had not seen anybody else do a pure, exact replication of the study. So in 2015, might have even been 2014, I attempted to replicate the study. And we did not get the outcome that he got after running. He had 15 participants in each condition. We did 15 participants in each condition. We'll talk about how many participants you need in a condition later, and I'll tell you that's more than enough if it's a robust effect. And so we had done everything basically the same way that he had, but in reviewing the protocol with my lab assistants, we realized that some of my lab assistants were we had a dummy cell phone that we would set on the table so that the lab assistant didn't have to put their own phone on the table. So we had one that, a brick, one that didn't turn on anymore and stuff. So we would just put that one on the table. And of course, the participants didn't know that it didn't work. So unbeknownst to me, one of my lab assistants was using her own cell phone as a timer for the cognitive tasks. And so I was like, well, maybe that is the reason why we didn't get a difference in performance, right? So let's redo the study, and let's all remember to use the stopwatch and not anybody's cell phone. So we did it again, and we didn't get the same results that the original researcher did. So we had another meeting, and we talked about protocol and exactly what had happened and what people had done. And we realized that when people signed up for the study, sometimes you would only get one person signing up for the study when we needed 2 to be in the study at a time. And some of the research assistants were running people by themselves. Like, if only one person showed up, they would just randomly decide if they were the experimental or the control condition, and they would run them by themselves. So we're like, well, maybe there's something fundamental about having 2 people in the room while you're doing it, and maybe that's why our outcome didn't come out the way the original researchers had. Well, flash forward to last spring, so that would have been 2019. We finally, I think, I got one lab assistant to run everybody. That way, because I was like, maybe the lab assistants aren't all doing the same thing. So I got down to one lab assistant who I completely trusted to do everything completely the same way for every single participant. Everything was done right, as far as I could tell. At least, let's put it this way, it was done completely consistently for every pair of participants who were run. We did not have any extraneous cell phones in the room. Like, everything was buckled up, and everything was completely exactly the way the original researchers had done it. We even discovered that we hadn't been exactly scoring it the way the original researchers had, so we went back and we applied that to see if that would fix it. I mean, we had tried to correct everything, and we still did not get the outcome the original researcher did. I finally feel like after 5 solid, diligent years of trying to replicate this study and doing everything we possibly could, I'm finally going to have to say, I don't think my data is supporting the original researchers. I'm going to finally have to say it's time to draw our conclusions and report our results, even though the results didn't support the hypothesis. But you might think to yourself that I was being stubborn and wouldn't stop trying to collect new data, but we kept thinking maybe there's something faulty in the way that we conducted the study, so let's do it again and tighten that up, and let's make sure we're all on the same page and we're doing it correctly. That's technically completely the scientific method. Hopefully the best scientific method, it would be not to make those mistakes in the first place, but it's really hard, right? It's difficult to all be doing it correctly all the time. But the first assumption has to be, probably did something wrong, let's review. And then when you finally convince yourself you've done everything exactly the right way, there's nothing else to say except for these appear to be our results. So we're finally at that point with that study. After 5 years of collecting and recollecting data, we finally have come to the conclusion this is what it is. So the steps of the scientific method can be quite time-consuming. I probably should have drawn an arrow between faulty study, new study, all the way back to the blue test hypothesis again, right, where you're going to run the study again. So I probably should have made this into a little bit more of a circle diagram, but I think you guys got the point. All right, I think that's a really good time to take a break in my lecturing, and we will come back in the next segment and talk about what is a theory and what is a hypothesis.